for today is Lee Chatelier's principle. So at first I will write the statement. The statement says if we make change in physical state of equilibrium mixture, if we make change in the physical state of equilibrium mixture, then equilibrium gets shifted. This is very important, okay? I will explain whole topic based on this definition itself. Equilibrium gets shifted in a direction which minimizes that change. So we will make a change in the physical state of equilibrium mixture, and then equilibrium will get shifted in a direction so as to minimize that change. So there are two key terms I have written. First thing is physical state of equilibrium mixture. So physical state of any substance, a pure substance or of a mixture, it is defined by state variables. What are the state variables? State variables are pressure, volume, temperature, and amount. If all the things are same, then we will say that given substance is at one single state. If all the things are remaining constant, if pressure is not changing, volume is not changing, temperature is not changing, amount is not changing, of a pure substance or of a mixture, means a mixture of different substances. If these things are not changing, then we will say that that substance is currently in one single state. Similarly, for our equilibrium mixture also, equilibrium will stay till any of these things are not changed for the whole of the mixture. Meaning to say, if mixture keep on exerting same pressure, is kept on the same volume, kept at the same temperature, and amount of the mixture is also same, then it will remain in the equilibrium state. Okay. So Lee Chatelier's principle says that if we make change in any of so if we make change in any of these variable, then its a state will change. Okay. For any substance to stay in the single state, all these things will remain constant. But if any of these things changes, then state changes. Equilibrium is a state. So from equilibrium state, it will be moving to a different state which is not equilibrium. Then again, to re-achieve the equilibrium will be shifted in a direction where this change can be minimized. I hope you're getting the sense of it. Lee Chatelier's principle is saying that, first of all, equilibrium is a state, okay? And then once that state is achieved, then these things would remain constant. But if we make change in any of these four variables which I have listed here, then equilibrium state will be disturbed. Now to re-attain the equilibrium will be shifted in a direction. So either forward or backward reaction will happen, and then equilibrium will be re-achieved by minimizing the cause. So let's discuss all the changes one by one. So I will discuss the easiest one first, like temperature. Change in temperature. change in temperature. So for instance, if I write this reaction to NH3 gas converting to N2 gas plus 3H2 gas. So can anyone tell me whether forward reaction is endothermic or exothermic?
So forward reaction is endothermic.
Endothermic. Why endothermic? Because this is simply a dissociation reaction, right? Decomposition of ammonia. So forward reaction is endothermic. When this reaction will happen, we will require heat. We have to supply heat. And for backward reaction, it is exothermic. So let's say this reaction was happening at temperature T1 and equilibrium was established. Now suddenly what we do, we make the temperature T2, which is greater than T1. Means we have supplied extra heat. If you are increasing temperature, now the new temperature is T2, which is more than the earlier temperature. So first of all, state got disturbed because one of the state variable got changed now. Our equilibrium mixture was firstly held at T1 temperature. Now suddenly we make the temperature T2. If we increase the temperature, then that equilibrium state got changed. Now either the forward or backward, one of the reaction will happen. So which reaction will happen? That will be determined by in which case this higher temperature can be minimized. And that can happen if endothermic reaction happen. Why endothermic now? Because endothermic reaction will eat up the temperature, eat up the heat which we are supplying. You're trying to increase the temperature, and that temperature you can feed to the forward reaction. Forward reaction want temperature. This is a decomposition reaction. So whenever we increase temperature, endothermic reaction get favored. Why it is so? We are increasing temperature, so the extra heat which we are supplying that is disturbing the equilibrium condition, that extra heat can be feeded to the forward reaction in this case, which is endothermic, or any endothermic reaction, be that forward or backward, it will be favored, and that will eat up that extra heat which we are supplying by increasing the temperature. I hope you're getting the point. So let me give you one more example. Let's say we have this reaction. H2 gas plus I2 gas getting converted to 2HI. Now someone tell me which reaction is endothermic here, forward or backward?
Backward.
Backward is endothermic. So if we increase temperature, which reaction will be favored, forward or backward?
Backward.
So it will favor the backward reaction, right? Because that extra heat, it can get fed to backward reaction, which is endothermic, which won't extra temperature. And equilibrium will be re-established.
Sir, what about if they ask like generally like rate of reaction?
Sorry, rate of
If they
reaction.
are, yes, sir.
Rate of reaction, what exactly is the question? Because rate and all, it will be taught to you in class 12, chapter chemical kinetics.
Sir, it's actually from today's CT. On
Uh-huh.
increasing the temperature, the rate of a reaction
Yeah. On increasing temperature, rate of reaction increases.
always increases.
Which one?
So
End
can
of
you like explain how?
no. What exactly is the question? Tell me. On
On
increasing
increasing the temperature, the rate of a reaction, there are four options. Always increases, always decreases, first increases, then increases, may increase or decrease depending on the nature of reaction.
valid question right now. Okay, we will change this. Please send the screenshot to me. This is kinetics question.
Okay, sir.
Okay.
Yes, sir.
I hope you guys understood this one. Change in temperature. Anyone has any follow-up question on what Akash was saying regarding today's CCT? On increasing temperature, rate increases, okay, but it will be taught to you in detail in class 12th. The whole chapter name is kinetics. Kinetics means rate. Okay, let's move to next part of it. Change in pressure. So let's say we are having this reaction N2 gas plus H2 gas, and they are forming ammonia. So initially, let's say we have 4 moles of nitrogen and we have 10 moles of hydrogen. And this reaction was happening at some temperature T1. So at this temperature, on achieving equilibrium, out of 4 mole, 2 mole reacted. I'm just taking a random data. Let's say only 2 mole reacted. So if 2 mole of N2 will react, then 6 moles of H2 has to react because 1 mole react with 3. And 2 into 2, 4 moles of ammonia will be formed. So we got 2 moles of N2, 10 minus 6, 4 moles of H2, and 4 moles of ammonia. Now this is the equilibrium mixture. Let's say this equilibrium mixture was kept in a container. I hope you all know that equilibrium can only be achieved in a closed container. So this was a closed container. And there is a one handle to the lid. And these are kind of hinges so that this lid cannot come upside. It has stopped over here. And over here we had moles of N2H2, moles of H2S4, and moles of ammonia also as a 4. Now what we did, we forcefully decreased the volume and again we put the hinge. So you can see here clearly, we have increased the total pressure of the equilibrium mixture. Now these moles have to stay in a lesser volume. So if the volume will be lesser, temperature is kept constant, then pressure will increase. Now these 10 moles, earlier we had 10 moles equilibrium mixture, 4 plus 4, 8 plus 2, 10 moles. They were in volume V1. Now they are in volume V2. Then obviously they will exert more pressure. So by doing this, we have changed the physical state of equilibrium because now the equilibrium mixture is exerting more pressure. So in this case, reaction will go in a direction where total pressure can decrease. What we have done, we have increased pressure. We have increased pressure. How we have increased pressure? By decreasing volume. So whenever this happens, then reaction will go in a direction where total pressure can decrease. Now to decrease the total pressure, we have to analyze the reaction. The reaction is N2 plus 3H2 ammonia. So if you see it, let's say we have N2, this is N2, N2 particle, then we have H2, H2 particle, and they are converting to ammonia. This single line is ammonia. So you can see here, out of 4 particles, only 2 particles are being generated. Whenever reaction going in forward direction, every 4 particles are converting to 2 particles. And when backward reaction is happening, 2 particle is converting to 4 particle. So I hope you understand this thing, that if number of particle inside the container will increase, it will exert more pressure. Correct? If number of particle inside the container will increase, then they will exert more pressure. What has already happened? By decreasing volume, total pressure has increased. So what if reaction goes in forward direction? So if reaction goes in forward direction, then every 4 particle, 1 and 2 and 3 s 2, every 4 particle will convert to only 2 particles. The number of particles inside this container will keep on decreasing and pressure will decrease. So when we increase total pressure by decreasing the volume, reaction goes to the direction where we have less number of gaseous particle. Like in this case, in forward direction. Reaction will go in forward direction. If we increase pressure, more ammonia will be formed. Any confusion, guys? Please ask me. Please ask me if anyone has any confusion.
Sir, you have taken two conditions, right? You have decreased volume and increased
Both
pressure.
happen simultaneously, right? If we decrease the volume, then pressure will increase. Both are studied all together, pressure and volume.
Okay.
So we have increased the pressure. So to decrease the pressure, what will happen? We should go to the direction where less number of gaseous particles are formed. So you can see here, if forward reaction will happen, then every 4 particle will convert to 2 particle. So that way we will take care of, that way we will minimize this change as per Lee-Chatelier's principle. Reaction will go in direction to minimize the change. The change was pressure got increased. So how we are minimizing it? By making this reaction go in forward direction, where every 4 particle will become 2 particle.
So if we decrease the volume, then the reaction will go in the forward direction, in the backward direction.
If we increase the
Go in the
if we increase
decrease.
the volume, yeah, if we increase the volume, or that means we decrease the pressure, then to build more pressure, reaction will go in backward direction.
Okay.
So this is the second condition. Now let's move to the third condition. Third condition is change in concentration.
Sir,
Yes.
sir, I have a doubt regarding today's chapter test.
Okay, ask it.
Sir, there were like four options in that which of the following equilibrium is not shifted by increase in pressure?
Mm-hmm.
The,
Can you
the
send
four
it?
options.
I will look into it, Akash.
Okay, sir.
Change in concentration. Okay, so let's say we have reaction PCl3 plus Cl2 forming PCl5. So how we can change the concentration of this equilibrium mixture? Let's say we're starting with 5 moles of this and 6 moles of this. At equilibrium, only 2 mole reacted, then 6 minus 2, and then 2 moles of this got formed. So we are having 3 moles of this, 4 moles of this, and 2 moles of this. This is initial condition. This is equilibrium condition. So concentration of this equilibrium mixture can be changed by increasing or decreasing any of the component. If you add more chlorine, or if you remove some chlorine, or if you add PCl3 or you remove PCl3, or you add PCl5 or you remove PCl5. If you change any component, overall concentration of the equilibrium mixture will change. So what if we increase the concentration of Cl2? If we increase the concentration of Cl2, then equilibrium will be shifted in a direction so that Cl2 can be used up In which direction Cl2 will be used up? Forward or backward? Anyone?
Forward.
Forward.
Forward. So increase in concentration of Cl2 will mean making the reaction go in forward direction. Let's say we are removing some PCl5. If you remove some PCl5, then reaction will go in a direction so that more PCl5 can be formed, and that is forward. If we add little bit of more PCl5, that will mean that PCl5 now needed to be used up. It will go backward. Okay. If we are adding PCl3, that means PCl3 need to be now used up. It will go forward. This is the simplest case. I hope you will be able to solve it. Is this clear? Please ask me if you want to ask further on this. All right, so let's discuss the next case. Addition of inert gases. Addition of inert gas in equilibrium mixture. So let's say we had one equilibrium mixture. N2 gas plus 3H2 gas making 2NH3 gas. Starting with some 10 moles of N2, 20 moles of H2. Then at equilibrium, we saw that 2 moles of N2 reacted. Then 2 into 3, 6 moles of H2 has to react. And 2 into 2, 4 moles of ammonia will be formed. This means we are left with 8 moles of N2, 14 moles of H2, and 4 moles of ammonia. This is the equilibrium mixture. Now we will be adding inert gas into this mixture. So before I do anything, let's recall the equation PV equal to nRT. So over here, in the gaseous mixture, if you are adding more moles, if you're increasing the moles, R will definitely not change. Then for the overall mixture, including the inert gas, other things will also be affected. Let's say temperature also we are not changing. Temperature we are keeping same. R will always will remain same. So on increasing moles, this PV will increase. If we change the temperature itself, then equilibrium will be disturbed there itself. Let's say we are keeping the temperature constant, then on increasing number of particles by introducing an inert gas in the mixture, this PV will change. So we cannot study both of them together. We will study both of them one by one. So first case will be, let's say we are maintaining same volume also. Volume is also same. We have added extra moles. R is also same, temperature is also same, then pressure will increase. So this is the case which we call addition of inert gas at constant volume. We don't mention constant temperature. Temperature is also constant. So to keep the volume constant, we have a very simple idea. Just take a closed container. Does not look same. Okay, so I just copy pasted. Now I have two equal volume. Okay, the first one has moles of N2 8, moles of H2 14, moles of ammonia 4. Second one has one more thing. Moles of N2 are 8, moles of H2 are 14, moles of ammonia are 4, and from outside we have added some inert gas, let's say helium. We have added some 2 moles. Now over here, the pressure was P1. Let's say they all together were exerting P1 pressure. Now over here, in the second case, with the inert gas, they will be exerting pressure P1 plus P. There will be some pressure due to helium. Keep in mind, volume is same, temperature is same. To analyze this situation, to comment on which direction reaction will move, at first we have to identify what has changed here. So let's recall our state variables. Our state variables were pressure, volume, temperature, or amount. Has the amount changed? Anyone, please tell me. Has amount changed of equilibrium mixture? Only focus on equilibrium mixture. N2H2 and ammonia. Has they changed?
No, sir.
No, right? They are still same. Has the temperature changed?
No, sir.
Volume is also same, right? What about the equilibrium mixture pressure? Pressure exerted by equilibrium mixture. Has that changed?
Yes, sir.
No, it hasn't. That's a tricky part. Now, total pressure got increased, but what about the pressure exerted by our equilibrium mixture? Has that changed? I have written P1. So pressure exerted by our equilibrium mixture is not changing. We are added something that is also exerting some pressure, but pressure exerted by our equilibrium mixture has not changed. Meaning to say that equilibrium mixture will stay in the same state. None of the state variable has changed. Are you getting the point?
Sir, but isn't the equilibrium mixture getting compressed? So it's exerting.
That's an extreme case. Let's say you fill so much helium that it start occupying a significant fraction of the volume available for them. Okay, usually the volume occupied by gaseous particle is negligible in comparison to volume available for them. Okay, then what will be this case? This case will be change in volume. Now for our equilibrium mixture, lesser volume is available. So if lesser volume is available, that means total pressure is increased. Then that will be a different case, but you don't have to think that much. That we have filled so much inert gas that it actually started occupying a significant fraction of the total volume available. Are you getting the point, Rishit?
Yes, sir.
Okay, but unless until that situation is reached or it is especially specified in the question, you will say that we won't see any change. Reaction will stay at equilibrium, it won't move to any direction. Because on adding inert gas in a constant volume, we could not change any of the state variable, so it will stay at the same state. It won't move to any direction, forward or backward. Guys, ask me if you have any question. Any question? No? Okay. Let's do the next case. So next case will be addition of inert gas at constant pressure. Okay, let's see how we can achieve that. I will write one reaction. Let's say we have this reaction. Let me take a different example. Okay, we can take any example. So let's say we have taken this example, and over here, in the beginning, we started with some 4 moles of CO and with 6 moles of O2. Then at equilibrium, 2 moles of CO reacted. So 6 minus half of 2 reacted, and 2 moles of CO2 got formed. So we got 2 moles of CO, 5 moles of O2, and 2 moles of CO2. Now these are kept in a container. This container has a piston which is actually movable, and there is no hinge on it. This is movable piston. Moles of CO inside this are 2. Just a second, I will just copy it, otherwise I will write something. Okay. So this is the first case. First case, we have moles of CO, H2, moles of O2, we have 5, moles of CO2, we have 2. This piston can go up and down, okay? So can anyone tell me what is the total pressure exerted by this equilibrium mixture? Anyone? What is the total pressure exerted by this gaseous mixture? This piston can go up and down. So when this piston will stop moving, when it will settle, then what will be the pressure inside?
1 atm.
1 atm, very good. Because this piston will only stop moving when pressure from outside and inside will be equal, right? So it should be 1 atm. Is this thing clear to everyone? This piston can go up and down. So this piston is stopping here because pressure has become 1 atm, right? Now what will happen? Let's say we fill the inert gas in this. So when we fill the inert gas in this, then it will increase the pressure inside and this piston will go up. So we have filled the inert gas. Moles of CO are still 2. Moles of O2 is 5. Moles of CO2 is 2. And some helium gas we have filled from outside. Its moles are, let's say, also 2. The moment you fill some inert gas in this piston will go up, right? And what will be the pressure now inside? Will it be 1 atm or more than that or less than that? Piston again got settled. Anyone?
So 1 atm.
It will still 1 atm, right? But now this mixture is occupying more volume, right? So we are able to maintain the same pressure, but volume got increased now. So this is the case with constant pressure and increase in volume. Right. Now what about our equilibrium mixture? How much pressure this is exerting, this mixture is exerting? Is it exerting 1 atm or less than that or more than that?
Less than that.
It is definitely exerting less than that, right?
Yes, sir.
Right. So pressure of equilibrium mixture plus pressure of helium is now equal to 1 atm. So definitely this is the case. This is the case when total pressure got decreased, right? Earlier this mixture was exerting how much? 1 atm. Now this is exerting 1 atm with the help of inert gas. So this mixture, our equilibrium mixture, is now exerting lesser pressure. So reaction will go in a direction in which total pressure can increase or more number of particles can be formed. So if you look at this reaction, so on the left hand side we have 1 plus 0.5, 1.5 moles particle are converting to only 1 mole particle. So in this case, definitely this will not help in building more pressure because every 1.5 mole will become 1 mole. But what if this reaction goes backward? If this reaction goes backward, then 1 mole will give you 1.5 moles. And that will help in building more number of particles and eventually more pressure for equilibrium mixture. Is this thing clear? So what you have to understand, earlier equilibrium mixture was exerting 1 atm in this case, right? Now with the help of inert gas, it is exerting the same pressure. Meaning to say that our equilibrium mixture is exerting now lesser pressure than it was earlier. So reaction will go in a direction so that more number of gaseous particle can be formed. Or you can say in this case, it will go backward. Please ask me question now. Topic has been taught.
Sir, it's from CCT. Sorry, not CCT, the chapter test.
You send me the image. Have you sent me the image?
Yes, yes, just a minute.
Shall I explain the role of catalyst also? Anyone?
So what kind of questions we get from this part?
First of all, conceptual questions. And application of this is everything, right? Like in the common ion effect, everywhere you are seeing the application of it only. Whenever we are adding any common ion, the reaction goes forward or backward, right?
Yes.
So in numericals, application of the Chatelier principles are there. But you should be
Yeah,
very
but
with the concept.
in like mostly it's concentration only, like temperature, pressure are very less.
Yeah, temperature pressures are less.
Yes.
So could you show the previous slide?
Yeah, sure. On increasing the temperature, the rate of reaction may increase or decrease depending upon the nature of the reaction. Akash, here they are like asking whether this is endothermic or exothermic reaction. Endothermic reaction rate will be favored, exothermic will not be favored, right? They have written the nature of reaction, so it is a valid question. Sorry,
Okay.
always increase is given as an option, right?
Yes, sir.
Okay, so it is correct actually, because in the kinetics it will be taught to you that rate of the reaction increases, but endothermic get more favored and exothermic get less favored. So when we talk about the reversible reaction, temperature actually favors both the reaction because kinetic energy of particles increases. So in this context, this should not have been asked. I will give this as a bonus marks, okay?
Okay, sir.
Are you getting the concept? What I'm saying over
Yes,
here,
sir. Got it.
when we increase temperature, the particles kinetic energy increases, okay? So actually rate of both increases. But endothermic reaction get more favored than exothermic one. So overall,
Okay,
it
sir.
is the effect. So endothermic reaction rate increases. Let's say both were earlier like this. We'll draw something here. Both were like this, okay? Now both will increase. Let's say this increased too much and this increased this much. So now you will see effective change in forward direction because this has increased more.
Sir, endothermic is increasing more because to utilize the extra temperature that's been.
Yes, to reachieve the equilibrium. But this will be taught to you in kinetics, so don't worry too much on it.
Sir, I also had like a doubt in one of the question in the CT itself.
I will just stop this recording, okay, for this topic. Anyone has any doubt in this topic, please ask me that first, then I will take other doubts. No? Okay. You guys can always send me message on WhatsApp, okay? If you need solution for any question or you need any clarification on the concept, please reach out to me on any chemistry topic belonging to inorganic or physical chemistry.
Okay, sir.